So in this unit, we are going to talk about measurement and some specific terms related to measurement. I mean, you guys are familiar with how to, I'm sure, measure the lengths of objects using rulers and perhaps in metric as well as imperial units such as inches and such. But what we really want to look at in this unit is how confident are we in the measurements that we take. Okay? And the first two terms we're going to talk about, and often these two terms are used interchangeably, but there's a difference between the two, and that's accuracy and precision. Okay? So accuracy, you can see there, it's how close a measurement is to the actual value of the measure, whether it's length, whether it's weight, whether it's height, and so on. Okay. Precision, however, is a little different in that if you measure the same object several times, would you get close to the same value every time? So accuracy is how close you are to the true value, and precision is if you did it several times, would those values be the same? So it is possible that something could be accurate but not precise, or precise but not accurate. And then we're going to move on and we're going to talk about precision of measuring instruments. That just means how many divisions they're broken down into. Like if you look at a standard ruler, and if you look at the metric side, you've got centimeters and millimeters. It's actually broken down into tenths. If you look at the other side, if it comes with an imperial measurement, you've got inches, but then you've also got, it breaks it down to half an inch, quarter of an inch, eighth of an inch, and even a 16th of an inch. So going back to accuracy versus precision. So let's look at this bent ruler. If you were to measure the length of something, okay, would you get an accurate result? No, because it's bent, right? Okay, so it's not going to give you it's not going to give you a value which represents the true value. However, if you measured over and over again, would you get close to the same value? So here's an example of something being accurate, but not precise. Or sorry, not accurate, but precise. So this ruler would not be accurate because it wouldn't measure the true value. Or true length, I'll say, because we're talking about length specifically using a ruler. However, it would be precise, or fairly, at least somewhat precise, if you measured the same length many times. We actually talked about this in statistics last year, for when you guys took it. And I gave you something similar to what we see on the second page. examples of accuracy and precision. Okay. So looking at each target and where whatever we threw at the target or shot at the target, we want to determine, was it accurate? Was it precise? Was it both? Was it neither? Was it one or the other? Okay, so if we look at A, accurate? No, because accurate would mean you're in the bullseye. So we would say not accurate. Precise? Yes. Because the shots, I'll call them, are close together. Several shots close together, so you're getting the same results, except you're off target, so you're not accurate. What about B? What did you think with B? It's not precise because if we shot several times, we're spread out. Accurate? Not really. Right. So not really accurate. I mean, not terrible, but definitely not precise. How about C? Both. You're on target and several shots are grouped around the same spot. So accurate and precise. And finally, D. Yeah, it's not accurate and it's not precise because they're pretty spread out. Yeah, I guess you could say it's precise in that respect, or somewhat precise. But probably I would just go ahead and say accurate. Well, definitely not accurate, and we'll say not very precise. Okay. Okay. So let's talk about precision problems. And how close can we get when we measure over and over again, right? Because can we get to the nearest whole number measurement, whatever that is? Can we get to the nearest one decimal place or 10th, nearest 100th, etc.? Well, it all depends on the information you're given. So in this one, the radius of a circle is 28 millimeters. What's the precision? Well, we would just simply say it's precise because this is a whole number to the nearest whole millimeter. Because that's as far as it's given us. If it said 28.2, we'd say it's precise to the nearest 10th of a millimeter, etc. So we would say precise, like I said, to the nearest. You don't need the word whole. I'll just put it in parentheses. If you're using a measuring instrument, well, it all depends on the divisions it's broken up to. Tells us how precise they are. So this one, is it broken up to the nearest whole centimeter, 10th, 100th, what? What would it be? There's a notch at every whole number, right? So wouldn't that mean whole centimeter? So precise to the nearest whole centimeter. Or I'll just put nearest centimeter. Which means all we can do when we measure these strings is go to the nearest whole centimeter. So therefore, every one of them would be 5. We know that C is going to be under 5, but we don't know how much because we're not given further divisions, are we? We know that B is greater than 5, but we're not sure how much because we're not given divisions between 5 and 6. And A looks like it's right on 5. But the best we can do with all of these, A, B, and C, 5 centimeters. But if you notice in the next example, it's now not precise to the nearest centimeter, but we broke it up into 10 notches in between each whole centimeter. So therefore, it's precise to the nearest 10. So precise to the 10th of a centimeter. Or we could say 0.1 because that's usually how we state. We don't usually write them as fractions. We write them as decimals. So now we can be a little bit more precise. So A, B, and C are no longer 5. We can be more precise. What would you say A is? Oh, I'm sorry, yeah, A is 5. I forgot they were upside down. Yeah, A would be 5. But did I express that correctly? Because remember, we have to go 10, right? So technically, you should say 5.0. Because we're asked to be precise to the nearest 10. B, 5.3 looks like. Just count the notches from 5. And C, 4.8. What about if we use the imperial gates on a ruler? We're told the precision in each of these. Okay? If you look at the notches, okay, the longest notches are the whole inches. The second longest notches are halfway between the whole inches, so those are the half inches. So what I need to do, because I'm asked to measure it to the nearest half an inch, it's not exactly lined up with a half inch result, but what's it closest to? 2.5. So we would say 2.5 inches or 2.5 inches. In this case, it's probably best to leave it as a fraction. If you look at the next longest division bars, it splits it up into quarters, but it also includes the half. Because remember, a half is 2 quarters. So it kind of goes like that. Right? So between every whole inch, there would be 2 1/4, 2 1/2, or 2 2/4, 2 3/4, 2 4/4, which is 3. So what would this one be? 2 3/4. You can put that for short. The next longest notches, or the second shortest notches, splits it into 8ths. And that also includes the quarters and the halves. Because a quarter is 2/8, a half is 4/8, and 3/4 is 6/8. So there's 8 notches to go from 1 inch, whole inch to the next. So we would be 2 and 1, 2, 3, 4, 5, 6. Yeah, I think we're closer to 6. So technically, we would say, oh, sorry, I should have put that down here. 2 6/8. We'll leave it at that because we're asked to answer to the nearest 8, even though we would want to reduce that to 2 3/4. Those are the 16ths. Yeah, notice we just cut it in half every time. We start at a 1/2 inch, and then we cut it in half, or we times the denominator by 2. So if we decided to go 16ths, we would go to this notch here. So how many 16ths would that be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's if we measured in 16ths. Okay. Just to wrap up with a couple other examples. And a little bit of refresher on perimeter and area. So a homeowner wishes to build a fence around her property. The shape of her property is a rectangle. Dimensions are 65 meters by 32 meters. How precise are the dimensions? Nearest meter. That's it. Define the perimeter. I can't, you guys since grade 9. Yeah. Like think perimeter highway. It's the distance around the city. Add up all the sides. Or in a rectangle, there's 2 lengths and 2 widths. We can just double the lengths and add double the widths. So we get 2 times 65 plus 2 times 32 will give us what? 130 and 64, 194, I think. Now we do length times width. So it'd be 7.8 times 9.4 And that answer would be 2 decimal places. 73.32 centimeters squared. Now make sure you answer the question here that's being asked. State the precision of each dimension. Not the area, the dimension. So because notice the area has a different number of decimal places than the dimensions do. So what would we say is the precision of the dimensions? Nearest the dimensions. 10. 100 would be the precision of the area. And then finally, you can see where we use precision and accuracy in many different areas of life, like machining. I mean, if you're building a vehicle, and if you're not accurate or you're not precise, that vehicle is going to fall apart as soon as you get in and start driving it. Okay, you can see other couple of examples here, medications at the bottom. And again, it shows you the difference between precision, so that if you measure the same amount of medication, or if you get the same amount of medication every time you measure, that would be precise. And if you're getting the actual amount, that would be accuracy. Okay, that's it.